Hi dear children, welcome to today's class. Today we are going to discuss exercise 6.2. First question. Show that the function given by f of x is equal to 3x plus 17 is strictly increasing on capital R. We need to show that f of x is equal to 3x plus 17 is strictly increasing on capital R. So what we will do is, first we will take some arbitrary numbers x1 and x2 that belongs to capital R, x1 and x2 that belongs to capital R, such that x1 less than x2. We will take some arbitrary real numbers x1 and x2 such that x1 less than x2. Now, since x1 is less than x2, if you multiply this inequality throughout by 3, you will get 3x1 less than 3x2. 3x1 less than 3x2. Now just add 17, then we will get 3x1 plus 17 less than 3x2 plus 17. 3x1 plus 17 less than 3x2 plus 17. What is this 3x1 plus 17? F of x is 3x plus 17. Then 3x1 plus 17, that is our f of x1. And thus 3x2 plus 17, that is our f of x2. Now what we got? If x1 less than x2, then f of x1 is less than f of x2. If x1 less than x2, then f of x1 is also less than f of x2. So we can say that our function f is strictly increasing on capital R. Second question. Show that the function given by f of x is equal to e raised to 2x is strictly increasing on capital R. We need to show f of x is equal to e raised to 2x. F of x is equal to e raised to 2x is strictly, f of x is equal to e raised to 2x is strictly increasing on capital R. That we need to prove. Now, same method, we will consider x1 and x2 belongs to capital R. And suppose this x1 is less than x2. Suppose this x1 is less than x2. Then 2x1 is also less than 2x2. If x1 less than x2, then if you multiply that inequality throughout by 2, then we will get 2x1 less than 2x2. This implies e raised to 2x1 is less than e raised to 2x2. If 2x1 is less than 2x2, then e raised to 2x1 is less than e raised to 2x2. And this implies f of x is e raised to 2x. Then this is f of x1 and this one is f of x2. So we will get f of x1 less than f of x2. So if x1 less than x2, then we got f of x1 is less than f of x2. Hence, f is strictly increasing on capital R. Hence, f of x is strictly increasing on capital R. Third question. Show that the function given by f of x is equal to sin x is, the first one is strictly increasing on 0 pi by 2, strictly decreasing on pi by 2 pi, neither increasing nor decreasing in interval 0 pi. We need to prove for the first one, this f of x is strictly increasing on 0 pi by 2. F of x is strictly increasing on 0 pi by 2. Third one. Here, I'm going to use that theorem. F of x is equal to sin x. F of x is equal to sin x. Then f dash of x is equal to cos x. And that theorem says that if f dash of x greater than 0, if f dash of x greater than 0, then the function is strictly increasing. This implies increasing. And if f dash of x is less than 0, then the function is strictly decreasing. This is our theorem. If f dash of x is greater than 0, then the function is increasing, and if the f dash of x is less than 0, then the function is strictly decreasing. So we got this f dash of x, that is our cos x. Now just consider the graph of cos x. Consider the graph of cos x. Pi by 2, pi. We need to consider it up to pi. So it is enough. And thus minus pi by 2. Now I am going to draw the graph of cos x. We know that cos 0 is 1. Cos 0, 1. And this cos pi by 2, that is 0. And cos pi, the value is minus 1. Okay. So just consider the graph of cos x. We are going to consider the graph of cos x. And cos 0, that is 1. Cos pi by 2, 0. And cos pi minus 1. Okay, now just join this. Okay, just join that 3 points. Then we will get the graph of cos x in the interval 0, pi. Cos x in the interval 0, pi. Now, for the first question, in that first question, we need to prove strictly increasing on 0, pi by 2. Okay, so we need to consider the interval 0, pi by 2. We need to consider the interval 0, pi by 2. And we know that in the interval 0, pi by 2, the graph of cos x lies in the positive direction, in the positive side. Okay, the graph of cos x lies in the positive side of y-axis. The graph of cos x lies in the positive side of y-axis. So we can say that in the interval cos x is greater than 0. In this interval cos x is greater than 0. But for the second question, pi by 2 pi, that is our interval. And if you consider the interval pi by 2 pi, we can see that this graph lies in the negative side of y-axis. Graph lies in the negative side of y-axis. It means cos x is less than 0. It means cos x is less than 0. Right? So in the interval 0 pi by 2, cos x is greater than 0. And in the interval pi by 2 pi, cos x is less than 0. Cos x is greater than 0 because the graph of cos x in the interval 0 pi by 2 lies in the positive direction of, in the positive axis of y-axis. The positive direction of y-axis. And in the interval pi by 2 pi, it lies in the negative side of y-axis. Cos x graph lies in the negative side of y-axis. Therefore, this cos x is less than 0 there. Now, this cos x, that is our f dash of x, and what we got is f dash of x is greater than 0. And by using this theorem, if f dash of x is greater than 0, then our function is strictly increasing in that interval. Now, for the second one, cos x less than 0 means this f dash of x is less than 0. If this f dash of x is less than 0, so in this interval, our function is strictly decreasing. Our function is strictly decreasing. Now, if you consider this 0 pi, the interval 0 pi, if you consider the interval 0 pi, here actually 0 to pi by 2 it is increasing, and pi by 2 pi it is decreasing. And if you consider this full interval, we can say that in that interval f of x is neither increasing nor decreasing. F of x is neither increasing nor decreasing in the interval 0 pi. So for third one, the interval 0 pi, neither increasing nor decreasing. That is not increasing or decreasing in that interval. Fourth question. Find the intervals in which the function f given by f of x is equal to 2x square minus 3x is, first one strictly increasing, second one strictly decreasing. So here we have one polynomial and we need to find the interval in which that the given function is strictly increasing and strictly decreasing. So in this type of questions, first we will find out our f dash of x corresponding to the given function. Here f of x is equal to 2x square minus 3x. F of x is equal to 2x square minus 3x, and thus f dash of x is equal to that we will cut it as 4x minus 3. F dash of x is equal to 4x minus 3. Now we need to find the interval in which the given function is increasing or decreasing. We need to find that interval. For that, what we want to do is we need to take this f dash of x is equal to 0. F dash of x is equal to 0. This implies 4x minus 3 equal to 0. If you took f dash of x is equal to 0, we will get 4x minus 3 is equal to 0. And this implies 4x is equal to 3. 4x is equal to 3 and x is equal to 3 by 4. If 4x is equal to 3, and we will get x is equal to 3 by 4. Now just consider the real line. Then suppose this is our 3 by 4 and this is minus infinity and this is plus infinity. That means the point x is equal to 3 by 4 divides the real line into two intervals. The point x is equal to 3 by 4 divides the real line into two interval. The first one is minus infinity to 3 by 4. We are not including that 3 by 4. Minus infinity to 3 by 4 and 3 by 4 to infinity. 3 by 4 to infinity. We are not including this 3 by 4. It is open bracket. Why we are not including this 3 by 4? Because if you include this 3 by 4 in that interval at this point, this f dash of x equal to 0. We need to check the sign. Is it greater than 0 or less than 0? That we need to check. So we are not including that point 3 by 4. So we got two intervals. Now consider one table. The first column, that is intervals, and the second column sign of f dash of x, and third column nature of f of x. Nature of f of x. So intervals in this case is minus infinity to 3 by 4 and 3 by 4 to infinity. Minus infinity to 3 by 4 and 3 by 4 to infinity. And what is our f dash of x? That is 4x minus 3. F dash of x is 4x minus 3. Now just take one point from this interval. Minus infinity to 3 by 4. So we can take x is equal to 0. No problem. Take some arbitrary point from this interval. I am going to take x is equal to 0. If x is equal to 0, thus we will get it as 4 into 0 minus 3. That is minus 3. 4 into 0 minus 3. That is minus 3. Then what is the sign of f dash of x? That is negative. And 3 by 4 to infinity. 3 by 4 to infinity, you can take any number. So I am going to take 3. Okay. For this I am going to take 3. So 4 into 3 minus 3. That is 12 minus 3 is equal to 9. So in this interval, the sign of f dash of x is positive. So if you want to find out the sign of f dash of x, just take some arbitrary point from the interval. Can substitute it and check the sign of your f dash of x. So I got it as negative and this one is positive. If f dash of x is negative, then the nature of f of x, that is decreasing. And if f dash of x is positive, then the function f of x is strictly increasing. So for in the interval minus infinity 3 by 4, the function f of x is decreasing, and in the interval 3 by 4 to infinity, the function f of x is increasing. So if you want to find out the interval in which the given function is increasing or decreasing, and if it is a polynomial, you need to find out f dash of x. After that, equate that f dash of x is equal to 0. Then you will get some points and just mark that points on the real line. Then you will get the intervals. After that, draw this table and consider the intervals and check the sign of f dash of x. According to the sign of f dash of x, we can find out the intervals in which our function is increasing and decreasing. Fifth question, we need to find the interval in which the f of x is equal to 2x cube minus 3x square minus 36x plus 7 is strictly increasing and strictly decreasing. So we will find out f dash of x, that we will get it as 6x square minus 6x minus 36. 6 is common, just take it outside, then we will have x square minus x minus 6. And this x square minus x minus 6, we can factorize it as x minus 3 into x plus 2. This is a quadratic polynomial, and that we can factorize it as x minus 3 into x plus 2. Now, f dash of x is equal to 0 implies 6 into x minus 3 into x plus 2 is equal to 0. That implies x minus 3 equal to 0 or x plus 2 equal to 0. Anyway, 6 cannot be equal to 0. So, x minus 3 equal to 0 or x plus 2 is equal to 0. If x minus 3 equal to 0, we will get x is equal to 3. If x plus 2 is equal to 0, we will get x is equal to minus 2. And consider the real line minus infinity to infinity, and we got two values for x, that is minus 2 and 3. Suppose this is minus 2 and this is 3. We got two values for x, that is minus 2 and 3. Now just look at that real line. Minus infinity to minus 2, that is our first interval. Minus 2 to 3, that is our second interval. And 3 to infinity, that is our third interval. So in this case, we have three intervals. For minus infinity to minus 2, the interval is open interval minus infinity minus 2, and minus 2 to 3 and 3 to infinity. This is our three intervals. Now we need to check the sign of f dash of x in this intervals. So we will draw the table. Interval, sign of f dash of x, and nature of f of x. Intervals minus infinity to minus 2, minus 2 to 3 and 3 to infinity. And what is our f dash of x? That is 6 into x minus 3 into x plus 2. 6 into x minus 3 into x plus 2. That is our f dash of x. Now we need to check the sign of this f dash of x in this interval minus infinity to minus 2. You can take any arbitrary value from this minus infinity to minus 2. I am going to take minus 3 from this interval. Minus infinity to minus 3, I am going to take minus 3. Then f dash of x is equal to 6 into x is minus 3. So minus 3 into minus 3 plus 2. That is 6 into minus 3, that is minus 6. So 6 into minus 6 into minus 3 plus 2, that is minus 1. So finally what we will get? 6 into 6, 36 we will get. 6 into 6, 36 we will get. That means the sign of x minus 3. Sign of this one is negative and this one is, that is also negative. So negative into negative, we will get it as positive. And just consider the second interval minus 2 to 3. Second interval minus 2 to 3. Anyway, 6 is positive. And what about this x minus 3 in the interval minus 2 to 3? I will take 0. 0 lies in the interval minus 2 to 3. So I will take 0. Then 0 minus 3, that is minus 3 and it is negative. And 0 plus 2, that is positive. Minus into positive, that is negative. Now 3 to infinity. Okay, 3 to infinity, we will take 4. Okay, we will take 4. If you took 4, 4 minus 3, that is 1 and that is positive. 4 plus 2, that is 6 and that is also positive. So this positive into positive, we will get it as positive. So if the sign of f dash of x is positive, positive means greater than 0, then the function is increasing, strictly increasing, and the sign of f dash of x in the second interval, that is less than 0, therefore the function is decreasing, and in the third interval the function is strictly increasing. So we can conclude that the given function is strictly increasing in the intervals minus infinity to minus 2 and 3 to infinity, strictly increasing in the interval minus infinity to minus 2 and 3 to infinity, and strictly decreasing in the interval minus 2 to 3, strictly decreasing in the interval minus 2 to 3. Seventh question. Seventh one, show that y is equal to log of 1 plus x minus 2x divided by 2 plus x, comma, x greater than minus 1 is an increasing function of x throughout its domain. We need to prove the given function is an increasing function in the given domain. So what is our y? Y is equal to log of 1 plus x minus 2x divided by 2 plus x. Log of 1 plus x divided minus 2x divided by 2 plus x. Then we will take the derivative. Dy by dx is equal to the derivative of log of 1 plus x is 1 by 1 plus x minus, we need to find out the derivative of 2x divided by 2 plus x. We need to find out the derivative of 2x divided by 2 plus x. Then we need to use u by v rule. Then we will get 2 plus x into dy dx of 2x minus 2x into dy dx of 2 plus x all divided by 2 plus x all square. And this is equal to 1 divided by 1 plus x minus 2 plus x into the derivative of 2x is 2 minus 2x into the derivative of 2 is 0 and the derivative of x is 1. 0 plus 1 all divided by 2 plus x all square. All divided by 2 plus x all square. And this is equal to 1 divided by 1 plus x minus, this is become 4 plus 2x minus 2x all divided by 2 plus x all square. And it is equal to that plus 2x and minus 2x get cancelled, and we will get the derivative, that is equal to 1 divided by 1 plus x minus 4 divided by 2 plus x all square. 1 divided by 1 plus x minus 4 divided by 2 plus x all square. Now just take the LCM, and after taking LCM we will get it as x square divided by 1 plus x into 2 plus x all square. X square divided by 1 plus x into 2 plus x all square we will get after taking the LCM. Now the given domain, that is, what is our given domain? X greater than minus 1. If x greater than minus 1, we know that if x greater than minus 1, or we know that this x square of any number is always positive, and if x greater than minus 1, this x 1 plus x is also greater than 0 and 2 plus x is also greater than 0. That means all these terms in the derivative, that is greater than 0, so we can say that the derivative is greater than 0, and if the derivative is greater than 0, then the function is strictly increasing in the given interval.